Today we're going to be looking at Learning Target 2C, Solving Inequalities with Variables on Both Sides. This is just a quick review of your inequality symbols, less than, less than or equal to, and greater than or equal to. For this video, you'll want to have 4 slides done. I still want you to write down the flip rule because it's imperative that you remember this come a quiz or test. Then you're going to have 3 examples that you're going to be responsible for having where we solve an inequality given variables on both sides. So make sure that you have your Cornell notes set up so that you can take each of these pieces and have them to use on a test or quiz. Just a reminder one more time, that flip rule says that whenever we are multiplying or dividing by a negative number, we have to reverse the inequality symbol. So if it's facing one way, it's got to be facing the other after you've either multiplied or divided by that negative number. So in this case, when we divided by -3 on both sides, we had to flip our inequality symbol. Make sure you guys have that because when you go to graph these, that is vital. Now, first example of solving inequalities with variables on both sides. This is absolutely the same as when we solved equations with variables on both sides, except for this time it's just an inequality. So if we have 14 plus 7x is greater than x plus 4 plus 4x, our first step is to look and see if we can combine like terms on either side of the equation. Well, on the left-hand side, 14 and 7x are not like terms, so we can't combine them. But on the right-hand side, we can combine x and 4x to make 5x, and we just bring our plus 4 down. Now we have our equation 14 plus 7x is greater than or equal to 5x plus 4. Our first step would be subtracting 14 from both sides, so that leaves us with 7x on the left is greater than or equal to 5x minus 10 when we combine the 4 and the negative 14 on the right-hand side. Then we want to move the 5x over, so we subtract 5x from both sides, giving us 2x is greater than or equal to negative 10. And to solve this, we divide by 2, which we don't need to use the flip rule because we're dividing by a positive number. So we get our solution of x is greater than or equal to negative 5. If we look at a second example, in this second example, we have to combine like terms on both sides of our equations, of our inequality, to make sure that we have it set up properly prior to solving. So on the left-hand side, we can combine -6 and -1 to make -7. And on the right-hand side, we can combine -9x and positive 3x to make -6x. So our inequality that we're going to solve is -7x minus 7 is less than or equal to -6x minus 8. First step, we're going to add 7 to both sides to cancel our 7's here. When we do that, we are left with -7x. So we have -7x is less than or equal to -6x minus 1 when we combine -8 and positive 7. Then we want to move this -6x over to the other side. So the opposite of subtracting 6 is adding 6. So we add 6x to both sides. And that leaves us with -1x is less than or equal to -1. In order to solve this, we now divide by -1. Now this is highlighted because when we're dividing by a negative, we have to reverse the inequality symbols. So now instead of being less than or equal to, it is now greater than or equal to. So our answer is x is greater than or equal to positive 1 because 2 negatives make a positive. We're going to go through one more example for you guys prior to class tomorrow. In this example, we add in the distributive property. You guys have done this before, and when you see it, it'll be something that should be a refresher for you. So initially, we have to distribute. That's our very first step. So we take the 8 and we multiply it by x. So 8 times x gives us 8x, and 8 times 5 gives us 40. Now we can look to combine our like terms. On the left-hand side, there's nothing to combine. Negative 5x and 22 are not like terms. On the right-hand side, we can combine the 40 with the 8 to make 48. So our inequality that we're solving is negative 5x plus 22 is less than 8x plus 48. Our first step is we're going to subtract the 22 from the left-hand side, and when we subtract it on the right-hand side, we get 26, so we're left with negative 5x is less than 8x plus 26. Then we're going to subtract 8x over. So if we subtract 8x over, negative 5x minus 8x gives us negative 13x is less than, we're left with 26 on the right-hand side. And then to solve this, we have to get x by itself, so we're going to divide by negative 13 on both sides. And again, this is highlighted because when you divide by a negative, or when you multiply by a negative, but in this case we're dividing, you have to flip the inequality symbol. So now instead of it being less than, it's now greater than. So our answer is x is greater than negative 2, because 26 divided by negative 13 gives us our negative 2. Make sure you have reviewed and that you have the flip rule, example 1, example 2, and example 3 in your notes, and bring any questions you have to class tomorrow.